Hello once again. Today we are going to be dealing with some inequalities. We've been doing some stuff with equations. Now we're going to add little arrows in here a little bit, but not that big of a deal. A little bit chunky of a lesson, so if you need to take a pit stop in the middle, go grab yourself a beverage or a snack and come back in a little bit, totally understand that. But I'm going to be here for the duration, so here we go. When we start talking about inequalities, okay, first thing we're going to take a peek at is what we got up in the box here. When we're looking at that little arrow in between, besides knowing if it's greater than or less than, it's also going to tell us if something is or equal to or not. So if we include the values that are with the arrow. So if they're just greater than or less than, we're going to use parentheses. If they are or equal to, greater than or less than or equal to, we're going to use brackets to show that. And we're going to show that in our interval notation and on our graph. So here's what we mean by this. We're going to have to write and graph solutions in interval notation. So if my solution is x is less than 3, you're like, okay, Hardy, how did you know x is less than? When the arrow points at x, that's less than, okay? So x is less than 3. I'll just make myself a verbal note here. So if I need to look at it later, I can still pick up on that. So when I graph this, we always want to have at least 3 lines on our graph. You're like, why 3? Well, because if I just stick 3 in the middle and I put my arrow the wrong way, I don't know if you know your number sense or not. So when we're looking at a number line, the numbers that are less are on the left. No, I'm not done yet. You wish I was. Or my numbers that are greater get bigger on the right. Okay, so if my value is less than 3, less than goes left. That's always the way I've remembered it. They both start with L. It's the easiest thing to remember. Less than goes left. And then for my symbol, since it's just less than, I use a parenthesis to say, hey, I'm starting right here and I'm taking all the values that are less. And so when I do my interval notation for that, that's always going to work on my graph from left to right. So if I look at my graph, this arrow is going forever, ever off the sheet, off the screen, off everywhere. And it goes down, down, down. 1, 0, -1, -2, -3, to something we call negative infinity. If you see arrows on these graphs, there's going to be an infinity of some sort. To the left, it'll be negative. To the right, it'll be positive. And then I keep following this graph to the right, until I run into this symbol at 3. Parenthesis at 3, parenthesis at 3. So that's how these work once we get to the solution. And then the same type of idea on the second one. Okay? X is greater than, if the arrow is eating x, it's like, I am greater than you, I will get bigger, I will eat you. Let me see if I can get my hand in the right place here. Okay, there we go. So x is greater than or equal to -2. What does that or equal to change about my graph or my interval notation? Let me show you. Along with dealing with our first issue with negative numbers. Okay. Think about this one for a second. When I'm graphing, actually, I'm going to give you 2 options, and I'm going to want you to think about this for a minute. Okay, I'm going to have 2 number lines here with number 2 in the middle. You don't have to do this on your paper. I just want you to kind of watch. Okay. Which one of those number lines is correct number-wise? I'd do the Jeopardy theme, but that's so old with this. Okay, I've given you a chance to think about it. Hopefully you picked this one. Because when we're counting, numbers go down in value as they go to the left. Okay? Would you rather owe somebody $2 or $3? I'd rather owe them 2. 3 is less of a value. Would I rather owe somebody $2 or only owe them $1? I'd rather only owe them $1. So I'm increasing in value as I go to the right. So negatives, we just flip that around a little bit. Okay? So when I go to graph, greater than goes to the right. So I'm going to be going to the right here. Make sure that arrow gets on to let everybody know we're heading to the right. Greater than or equal to, which means my solution set is going to include -2. When I use a parenthesis, we use the numbers right up to it. So like we do 2.999999999 would be a part of the answer, but 3 wouldn't. So it's kind of getting used to some of that lingo a little bit. And then our interval notation, again, left to right, starts at my bracket at -2 this time. But as it goes to the right, it's going forever to the right to positive infinity. Okay? Forever left, -infinity. Forever right, positive infinity. And yes, it matters. Okay? It absolutely does. So now we're just going to combo that with what we've already learned before. Okay? Solving inequalities with variables on the side. So, first things first, we're going to be old hands at this by now. Find your variable you are isolating. Do what you got to get by itself. Opposite of -7 is +7. That's a whole lot of bell ringing. And as we've spoken about before with these, you can do these in one step or two. You could multiply by 2 to get rid of the fraction and then divide. Or you can multiply by the reciprocal. Again, if you're going to use the calculator on this portion, make sure you're putting the fraction in parentheses. Okay? So 9 times 2/3 is 6. Okay? So there's my inequality. X is by itself, we're good. Probably should have put that where it says solution, so that would go right here. Okay? The graph, again, minimum of 3 values. You can do more if you want to. But as you think of it this way, as you go left, keep subtracting 1. So 5 minus 5, Freudian slip. 6 minus 1 is 5. And going this way, we plus 1. 6 plus 1 is 7. So at 6, am I going to use a parenthesis or a bracket? A parenthesis. It's not or equal to. And since we are heading to the right, because x is greater than, chomp, greater than, I just got bigger because, I got my extra values in there. So we've got our arrow, and then our interval notation just goes left to right. Here's my furthest point left on the graph at 6. Forever to the right. Okay? Now, are there a few exceptions in these? There's exceptions in everything in math. Let's be real here. So let's deal with that here in number 2, and then I think we can kind of start to roll a little bit here. I have a feeling we'll be all right with these. So here, okay, x term by itself. Now this one's a little tricky, like 5. What do I know? Do I go with that sign? No, that's a positive 5. What's the opposite of a positive 5? A negative. Little details. Okay, here's where our twist comes in. Get x by itself. What do I have to do? I'm multiplying it by -2. That negative's not in between. I'm not adding here. I'm going to I was multiplying. So I'm going to divide by -2, and that's going to change something. Check out our note. When you multiply or divide both sides by a negative, that's what we just did. Reverse, flip the inequality. So the arrow flips. If I forget to do that, I'm going to get the actual opposite of the answer that I want. So there's my solution. Take a little time here. Remember, 1 less as we go to the left. When we're in negatives, Make sure we're getting there. 1 plus 1, 1 more as we go to the right. You could even do it on the calculator if you weren't sure. Okay, negative 11 plus 1. Oh, negative 10. And get it there. So negative 11, bracket, because it's or equal to, and less than because the arrow is pointing at the x. Now, I do want to take one thing on here before we go on any further, because I'm going to have me some arrow followers out there. I know this is going to happen, because you're looking at the ones up above and the two we just did, and you're like, Hardy, every single time, if the arrow is pointing left in the inequality, we're going left. If it's right, we're going right. That's happened every single time. Why am I not just following the arrow? That works if your x is on the left side. Now, if you get into a situation sometime, though, that the x is on the right, that won't work. It's a trap. So I always tell people, eats x, getting bigger, greater. Pointing at x, you are less than me. You are less. Like when somebody's wagging their finger at you, kind of like I am right now. Okay? That's the way I would rather look at it. Otherwise, you can always try to get your x on the left, and that may work as well. Okay. So the next part, solving with variables on both sides. Now, let's be honest here. There's nothing really different about these than the other ones. We're just kind of, so if you're doing pretty good with this, maybe you can fast forward me through 4 and come back for 5, but it never hurts to be here. So for my people who are like, well, I'm just going to stay on the left. If I can just arrow follow on the left, that's what I want to do. And you can. I'm not going to be mad at you if you do. And then just keep doing your thing. Keep doing opposites. And I'm assuming at this point, if you've been practicing at all, you're an old pro here. Now here again, especially when we're new at this, we got to be careful. Because I'm going to have some people here that are going to tell me, hey, Hardy, you screwed up. It does happen. It probably will on a couple of these videos. I didn't hear though. Well, wait a minute. You didn't flip the arrow. There's a negative there. Remember, the rule for this is both sides by a negative we flip. Okay? We're not dividing by a negative here. That's positive 2. It just so happens there's a negative up top. It's only when you're doing it to both sides for your step. So again, get your value in the middle. Less 1 as you go left. 1 greater as you're going to the right. Now again, m's on the left. I guess we could arrow follow, but again, you are less than me. So less than goes left, or equal to gets me my bracket. And now we just follow that for interval notation. From left, oh, arrow's going left forever, negative infinity, to right. And we're good. Okay? Mainly on these, it's not going to be, I don't think for a lot of you, the graphing or interval notation, it's going to be making sure we don't do something silly up here. So let's knock this one out. And then we can get into one more piece and we'll be good. If there are parentheses, we're dealing with that. First, make sure you distribute to both terms. Now it looks a lot like number 4. Okay? Now, for my, I'm going to throw a twist at some of you. Now, if some of you want to keep moving everything to the left, you go ahead. I like to keep things positive. So, I'm going to do something a little different here. I will show you in a minute that either one of these ways we're going to do is going to work. Again, if you wanted to plus the 4x over it, do it. We're going to end up in the same place at the end. So I get that to that side. The goal is to get x alone. I'm adding 12 to it. I'm going to minus 12. And this is going to give me a prime opportunity to show you how there's 2 ways to get to the right answer. And it's going to be a comfort level for you is what I'm going to basically say. So let's say some of you decided you were going to keep, everything staying to the left. I don't want x over here. Hardy, that drove me crazy. Okay, so let me make a quick jot here of where we were. And so then you decided that you were going to plus 4x. Now, just to show you, the best thing you can do in math is jump in somewhere. You're like, okay, so I want to get this alone. I got to get that positive 5 out of there. Okay. Ooh, but this time I divided both sides by a negative. So, flip the arrow, change the sign. So let's look at these for a minute because they say the exact same thing. X is less than or equal to -7. Now, that's the more classic way we look at it. But remember when I said, if the arrow's pointing at X, you are less than me. Same thing. They're both the same. So be careful, okay, when you're looking at these. They both get me to the same answer, so however you want to do it is fine. So we've got our solution, okay, our graph. Again, with negatives, be careful. Take 1 away. Now I owe 8. Pay 1 back. Now I only owe 6. And if you don't have your arrow following, again, less than is left. Or equal to is a bracket. Just keep playing with it. It's like anything else. It's like video games when you first start doing your bad, then you get a hang of it, and you're like, oh, this is easy. You kind of roll it out. Left to right. Okay? So the last twist we are going to throw in today, like I said, this is a chunker of a lesson. I'm not going to lie to you. Is dealing with compound inequalities, when there's two inequalities together, the way they look and the way they're written. And they're going to be introed with either the word and or. So let's flip over and I can show you a bit here on what the difference is with those and how we would pay attention to this. Okay, love the notes on this. And is restrictive and doesn't have as many answers. And it makes like a sandwich. What do you mean? Because a sandwich, you got 2 pieces of bread and then you got your meat and cheese or veggies or something in the middle. That's what your and statements are going to end up looking like. They can be a 3-part inequality like this, or sometimes they can look like okay, they can be written either of these ways. Oops, except it's not the word or, Hardy. And. Okay? They can be written one of 2 different ways, but they mean the same thing. So you're like, okay, here's something we haven't seen. What the heck am I supposed to do? I'm supposed to be getting t by itself, but there's like all these other places and things. What do I do? Okay. If that was the side of the equation, what would you do? Well, I'd do the opposite of -8. I'd add 8. Okay. We're just going to do that now on each side where there's an arrow. Just going to do it one more place. That's all. So we'll get that in there. And now one more step. We're getting t alone. We're multiplying it by 3. We'll divide by 3. T's alone in the middle, and we're done. You're like, ooh. So how's this work as a graph? Well, a couple of ways we can look at it. Now, again, we want at least 3 numbers on here, but I know 1 is 2 and 1 is 6. What number's right in the middle of 2 and 6? 4. Okay, I don't have to count by ones. I could have 2, 3, 4, 5, 6. That's fine. No big deal. But if I do this, you're like, well, how do I graph it? Well, here's my way of looking at it. When it's a sandwich, you graph the 2 endpoints and you just color in between. So we'd have a bracket at 2, a bracket at 6, and we color in the middle. But mathematically, let's look at this for a minute because sometimes understanding mathematically helps. T is, the arrow's eating T. I'm greater than you. T is greater than or equal to 2. Going to the right. So here we were actually going to the right. So then I flip and I look at the other side and I go, okay, so t, is less than, or less than me, 6. I'd be going to the left and they just crash in the middle. Okay? So mathematically, that's why the sandwich comes into play with and. And then my interval notation is going to be really easy. Because now I just go left to right. So when I have an and statement, when I have my sandwich, it's just the endpoints with their symbols. That's it. Okay, so if we do that one more time here with number 7. Again, if you felt really comfortable with that and you tried a couple and you're good, fast forward me on 7, go straight to the ors here. But otherwise, again, getting that alone in the middle. Plus 3 for everybody. We're in there. Just like we did on the last one, we're going to divide by 3. And now you're like, oh, okay. So when I have it like this, well, now after listening to that last one, now again, when we're making graphs, now this one's going to be a little more tricky. I can't just put -3, 6 and put a random number in the middle. We've got to show number sense. So again, if you decide you're going to go this route, okay, 3 and 6 are both multiples of 3. So I can count by 3s to get in there. Or I can put all the values. That's fine. But we can't have just these kind of silly number gaps in the middle. And now the same thing. So we've got or equal to here. So a bracket on -3, just less than on 6. So we can mix and match with symbols and get that in there. And finally, left to right. Watch your symbols. It matters. It does. Okay. Last part, you're almost there. Hopefully you've had a snack or a beverage or something. If not, hit pause and go do that. You have very much deserved it. I'm gonna give myself a break here a second. All right, I got enough in me now to get through these last two. Okay, or statements, different than and, different word in the middle. Non-restrictive, woo, they want to have all kinds of answers in here. Bring everybody into the party. Like oars on a boat. Oh, that's so clever. That's just clever. Just shout out to people who came up with this. Because here's what your graph is going to look like. You see where the or thing is coming from? You got your oars out there, you're rowing. Okay? So, or we got oars. That's what your graph should look like at the end. Or in the middle, 2 separate inequalities. So what do you do here? You solve them each on their own. Okay? So like we're going to forget that one's there for right now. Get this going. -3. Divide by 2. And again, if your expertise has gotten better and you can do that just by going from here to here to here and not showing all the minuses and divides, that's fine. If you need that still, absolutely acceptable. Absolutely. I just show it because I want to make sure when you're taking notes and having examples later that you have good examples and you know where everything came from when we're doing these. All right, and that or is important. That is our solution set. My graph, again, 1 and 4 are pretty close to each other, so I'm just going to do 1, 2, 3, 4 here. And now again, x is less than 1. Pointing at x, less than you are less than me. So left. X is greater than 4. There's my ors. Sweet, looking good. Now, interval notation. Okay, here comes our last little mini twist here. So you're like, how do I do this? So left to right. So left is forever to the left. And then I come to the right and I stop here at 1, but there's another piece to my answer. So what do? Well, I need to show the person that's looking at this that these need to be combined. They need to come together in union. We just put this U in the middle. And then we start over again. Left to right. And we're good. Okay? That's the goal here. And the only thing that can really twist things up at times, of course we got to save the double-starred one for last, right, is, well, you're going to see in a minute. Let's do these and see what happens. Some of you probably already see what's going on here and going, oh, let's see how crazily this messes things up here. Okay, what do I got to do to get x alone? Divide by a negative to both sides, which means we flip the arrow. Flip. Okay? We're going to make a note here. Flip. So we remember later if we're looking like, why do we do that? That's why. Okay, here, minus the 5, nothing real complex. Ooh, oh. Hardy, what are you doing? No flipping there. Don't do it. Divided by a positive, no flipping. All right. Now, it doesn't look like that's really going to mess with me as far as my graph goes. And that's a good thing. Keep them bells a-coming. X is greater than or equal to 2. Okay, so you're like, so greater than or equal to 2, greater than this way. Or x is less than 5. Okay, Hardy, wait a minute. This is looking like the sandwich. This is looking like an or. These are coming together. They're not going apart like ors like they're supposed to. Is something wrong? No. Okay. Oh boy. Well, what do? Well, this, as an arrow, this is going to keep right on going, right through your other endpoint. This is going to keep right on going. This is why I have to pay attention to the letters in the middle. If that's and, these come together. I'm done. No big deal. If it's or, you're taking everything. It's non-restrictive. They don't stop at those endpoints. Once the arrow goes, they're going. Well, what do then? It's forever to the left and it's forever to the right. You're right. Or it may be written as all reals. Ooh, Hardy, that was not kind to do. Does that happen very often? No. But if it does, you have to be aware. Okay? Ors, if it looks like a sandwich, if it looks like an and, it's infinite. Okay? And is the same thing. If it don't look like a sandwich, if it looks like ors, it's no solution. Oh, we're going to make note of that here at the bottom. If it's an and statement, and you get the arrows like this, no solution. That could come in handy sometime. Jot that one down. Hopefully you didn't fast forward and pay no attention here. We'll see. Thank you so much. Like I said, we're trying to make sure we don't get chunkers like this very often, but this is just, there wasn't a whole lot of ways around this because we needed to have all the things for you here to make this work for you. So again, you got some practice solving the inequalities and things. Always remember, you have solution help on the back there to get you going. Thanks again. I appreciate it so much, and we'll see you next time. And again, if you're going through this stuff and have questions, let me know. It's the only way I can help. Thank you. Have a good one.